Rock here with Simpson Math. Let's solve simple trigonometric equations or conditional identities, and let's discuss the periodic aspect of the solutions. Okay, so here I have a nice simple trigonometric equation. This is a conditional identity, meaning it's an identity only if x has certain values. And our goal is to find what those values are that will make this a true statement. In other words, we're solving an equation like we were back in the 7th grade when we first introduced ourselves to algebra. What we want to do is get this trigonometric expression that I've highlighted here by itself. So we have, maybe we need to blow that up a little bit, 2 times the trig function sine of x plus 3 equals 4. And we want to isolate the trig function. So the first thing we're going to do is subtract 3. That gives us 2 times sine of x is equal to 1. And remember, we're trying to isolate this. So the next thing we're going to undo is the multiplication. We'll undo that by dividing or multiplying by half. That undoes that, and so I'm left with sine of x is equal to 1/2. Now remember, the inputs to a trig function, we visualize them as radian measures of angles and standard position. And the outputs are the y-coordinate on the unit circle that angle would intersect the unit circle at. So what we're going to do here is let's look at the definition. So here's a unit circle, x squared plus y squared equals 1. And there are 2 angles in the first circumference or rotation around the circle. There are 2 angles that will intersect at a y value of 1/2. We have one right here, and we have another one right here. And the first one is at pi 6, or 30 degrees if we use degrees, and the second one is at 5 pi 6, or 150 degrees if we use degrees. So those are 2 solutions right away. Of course, we know that these solutions are periodic. Like this pi 6 solution, if I were to go another full 2 pi all the way around, I would hit again. So that means that there's more than just these 2 solutions. And that's the thing I want to talk about today, is how to identify all those solutions. Another way to visualize them besides the unit circle is, of course, on the sine wave. So we said that there should be a solution at pi 6. Well, if we look at this sine wave here, here's our typical sine wave. It has an amplitude of 1. It has a period of 2 pi, so it finishes one cycle over a horizontal axis length of 2 pi. And then it starts repeating itself. And it repeats itself both directions, okay? Now, we said that there would be a place where it's equal to 1/2, and we see it right here. There's one of them, and that corresponds to, here's pi halves, so 1/3 or of 1/2 is a 1/6. So that looks like about 1/3, and sure enough, here at a 1/6 is the solution where the output would be 1/2. Now it happens again. It happens again right here. That's another place where the output is 1/2. And if we come down, that looks like it corresponds with, sure enough, if we're going by 6, this is 1/6, 2/6, which is 1/3, 3/6, which is 1/2, 4/6, which is 2 pi thirds, and 5 pi over 6, which is the other point of the other angle we said would intersect the unit circle, where the intersection point would have a y-coordinate at 1/2. So you can look here to see the answers, okay? And we see that there's 2 in the first cycle. But of course, there's going to be a second cycle. So there's going to be another solution here and another one here. And then there's going to be a 3rd cycle and a 4th cycle. And there's going to be a cycle on the negative side. Here it's going to be negative, but it's eventually going to come up and go through, and then come up here and hit, and then come back down and keep its pattern going. So there's going to be a solution somewhere in here where it's 1/2, and over here where it's 1/2. So how do we find all these infinite many solutions for the equation? Well, that's quite simple. We're trying to find the solution. We simplify the equation to here. And all you do is find the solutions that you can find on the unit circle, which there's 2 of them. Then you recognize that the other solutions are either, they're all 2 pi, full period, removed from either this one or this one. So we say plus 2 pi, and we could do plus or minus here. I'm just gonna do plus, and we're gonna go times k, where k could be a whole number or a negative whole number. So if k is negative, then this would be negative 2 pi, which would subtract from pi 6. And if I back up 2 pi from pi 6, I land all the way over here. And if k is negative here, then I back up 2 pi from here, which lands me on this one. But if k is positive, then I would move forward. So if k is positive here, I'd move forward 2 pi from here, and I'd land there. But if k was a 2, I'd land 4 pi forward, so I'd go to the next one over out that way. So this takes care of all of it. You just have to announce what k is. K is an integer, meaning it's a whole number, 1, 2, 3, 4, 5, 6, or 0, or a negative whole number, negative 1, negative 2, negative 3. And this then is the solution to the equation. Now, in this case, there were 2 solutions. You can imagine equations where there's no solution. What if I had the equation sine of x equals 3/2? Well, notice that sine of x only goes up to 1. It only goes up to 1. It's never going to go up to 1.5. 1.5 would be up here. It's never going to hit that. So this would be no solution. What if we had sine of x equals 0? If we were solving an equation and it came out to be sine of x equals 0, well, we see that it equals 0 here and here and here. So we don't have to be so fancy and go 2 pi out. We could just say, hey, there's one basic solution here, x equals 0. And then you can just add 1 pi to hit this one, and 1 pi to hit that one, and 1 pi to hit the next one, or back up a pi and hit the next one. And so you just add pi. Okay, that's kind of a special case where k is an integer. Now, can we see that? Am I writing off the screen? Duh, I do that all the time, don't I? Okay, so, but this seems redundant to say 0 plus something. So in other words, we would just say x equals pi. Okay. It's all the whole number pi's. 0 pi, 1 pi, 2 pi, 3 pi, negative 1 pi, negative 2 pi, negative 3 pi, and so forth. And so this would be the solution to this equation. And this one would have no solution. So, to recap, you simplify the trigonometric expression, then you look for solutions on the unit circle and you write them all down, then you add the period to those solutions. And in some special cases, you might be able to find something simpler where you don't have to add a full period, but you can add just half of a period and hit them all. Or in other special cases, there may be no solution. And in the next video, we'll talk about what do you do when it's not a convenient value on the unit circle that we have memorized, and how do I find the solution then. Math made simple, Simpson Math.